Hello, everyone. Welcome. Thank you for attending our presentation. We're glad you're here. I know it is you've been enjoying the conference, but it is almost the end of the day, so we'll try to keep our presentation hopefully short and definitely interesting. Let me introduce myself. My name is Govind Kamat. I work on benchmarking tools and OpenSearch performance at AWS. And prior to this, my background has been in several domains. I've worked on electronic design automation software, compilers, simulators, before moving into distributed systems performance. My colleague and co-presenter is Hoang. He has considerable experience in benchmarking tools and automation, and also works at AWS. Some of the work we talk about is due to Rishabh Singh. He couldn't be here, but also works on the same team. If you're here, you're likely trying to figure out how to get a handle on the performance of your OpenSearch cluster. Perhaps you want to get an idea about how well your cluster is performing and if there is any scope for improvement. Perhaps you're encountering problems with your cluster, performance problems, and would like to get some idea on how to tackle them. If so, you can take heart in knowing that you're not alone. Before we delve deeper into the topic, it helps to understand that performance means different things to different people. And it has several facets, as you can see out here. For some people might be interested in ingestion. They are really interested in getting the maximum number of documents into their cluster as quickly as possible. And they probably are focusing on throughput. For other users, they may be much more focused on queries. They might, for instance, have complex queries with nested aggregations and have specific SLA requirements and want to get the best latency possible. For other users, the issue is right at the beginning when they are trying to decide upon the cluster specifications. How many nodes should they use? What kind of instance type would be recommended? And then after that, there are other questions. How many indices should they go with? What about the number of shards and the amount of data that comes in? So all of these have a bearing on the ultimate performance of a cluster. In addition, there are new technologies that are coming around, like tiered storage, for instance. You have multiple serverless offerings that are coming down the pike. And these days, you find vector databases and vector workloads as well. So how do you deal with performance with all of these dimensions? So our talk is divided neatly into three parts. We're going to start with an introduction to OpenSearch Benchmark. I'm going to just call it OSB from now on. And we'll tell you how to use it. The second part of the talk will be talking about using OSB to track performance. Before we look at improving performance, we need to know how to measure and track it, and that's what we'll discuss there. And finally, we'll look at strategies and techniques to customize OpenSearch Benchmark to your specific use case. So diving right in, what is OpenSearch Benchmark? So essentially, it is the de facto performance benchmarking tool for OpenSearch. So as you know, OpenSearch was forked off from Elasticsearch a couple of years ago. So at the same time, the benchmarking tool for Elasticsearch, which is Rally, was also forked. And we came up with OpenSearch Benchmark, which is fully Apache licensed. So the GA version of OpenSearch Benchmark was released last year. And since then, we are currently at version 1.5. Typically, we have a new version released every month. Now, when you use OpenSearch, you're typically using probably a Java program or a Python script or some other type of client. And OpenSearch Benchmark is essentially a client. Conceptually, fairly straightforward. So essentially, it sends out requests to your cluster. So at the moment when the request is sent out, it turns on a stopwatch. And when the response comes back, it turns off the stopwatch, so it can figure out how much time there is. But obviously, it's a complex benchmarking tool with a number of features. So once the test is completed, it will aggregate the results and present to you the information. What OpenSearch Benchmark does not provide out of the box are a few features, as you can see. Scale testing. For OpenSearch Benchmarking is a benchmarking tool, but some users might be interested in running workloads at large scales. Perhaps they want to look at performance tests against large clusters, or they want to start off a large-scale workload against a serverless offering to see whether it scales out or not. Other users might be interested in chaos testing, where they bring down one or more data nodes in a cluster, and they want to see how well the cluster will continue to function in those circumstances. They might want to inject faults into the cluster and test that out. Yet others might be more interested in long-running tests, where they want to see if the system runs out of memory, for instance. And finally, there are multi-tenant workloads and mixed workloads. I think John Handler had a talk about that a little while ago. So while OSB does not handle these directly out of the box, they can be emulated by the user customizing it with specific workloads and specific scenarios. Now, OSB, as I said, is a client, but it comes packaged with several workloads in various domains. Here is just a sampling of them. So you have NYC taxis. Now, you know, OpenSearch at a high level can be thought of as a search or information retrieval system, primarily for search or for log analytics. So NYC taxis is a search workload. It models taxi rides in New York and comes with a large complement of search queries. HTTP logs is a log analytics workload. So the data corpus for this workload is captured from the web logs for an Apache web server. GeoPoint, so if you're interested in geolocation and latitude, longitude, and you have your data corpus with all of these geopoints, you want to find out the distance between these geolocations, then GeoPoint is your workload of choice. These days, as we know, vector DB and ML workloads are all the rage, so we have a vector search workload that comes with OSB as well. And finally, in this set, there is the Big Five workload, which has been recently added. So as you know, searches in OpenSearch fall into 5 large areas. There is text search, range queries, sorts, aggregations, and data histograms. These are the 5 big areas. The Big Five workload comes with a large complement of queries in each of these areas. So how does OpenSearch Benchmark work? At a high level, you can see on the right side, there is a cluster with 3 data nodes. On the left side is a load generation host, where the user has installed OpenSearch Benchmark, and then you see a few workloads over there. When the test is initiated, the top arrow shows that it issues a bunch of requests for ingestion and queries, obtains the information when these queries are consummated and finished. And at the end of the test, the second arrow shows that OpenSearch Benchmark queries the cluster and captures metrics using the stats API, for instance. And once the test is complete, the results are presented to the user, and also optionally persisted in a data store. Now, in the interest of dogfooding, the data store is simply another OpenSearch cluster where you can store the results of your tests. And that helps you to compare one test against another and look at whether performance is improved or not. You can also visualize the results using dashboards. This basically goes through the same steps. When you want to run a performance test, you pick your workload of choice. You carry out ingestion initially. Once the documents are all within your cluster, you typically go through a merge phase that coalesces the leucine segments together and tries and ensures that there's less variance across the results. And then you embark on your query phase. Generally, as I said, when you do ingestion, you want to get your documents in as quickly as possible. So typically, you will use multiple threads to do your ingestion phase. For queries, you will typically use a single thread. And the idea is that you want to have repeatable, accurate results for latency. I mean, this is not hard and fast. It's very easy, trivial, in fact, to go ahead and use, change the number of threads. You could do ingestion with a single thread, and you could do queries with multiple threads if you want. And finally, as I said, you capture the results. Now, typical OSB workload is fairly straightforward. On the left side, you have a standard OpenSearch query. And on the right, you can see it has been converted into an OSB format. You have a query with a match-all query of a search type targeting the index logs. And there is a counterpart, which is the test procedures file, which basically strings all the operations together. So here we have 4 operations. We start off with index creation, then ingestion, which is index append, and then you have a merge operation, and finally the query that we looked at in the previous slide, which is the match-all. So you can choose to decide how long the schedule should be, how long these operations should take, or whether you want to have multiple operations happen concurrently. All of these are flexible options that you have within OSB. The data corpora are simply a set of documents. So here is a sample document from the NYC taxis document, data corpus. And as I said, NYC taxi models the taxi rides in New York. This document shows the starting point of a taxi ride, where the passenger was dropped off, how many passengers were in the taxi, what the cab fare was, and so on and so forth. So how does the OpenSearch Benchmark work? Here is a little animation. So we have an incantation right up front, and it goes off into the run. The index is created, ingestion, and then queries, and here are the results at the end. So you can see merges, and then you have a bunch of queries. So here is a blow-up of the results. So when the query is complete, this is the term query on the right side. And you can see, essentially, for instance, you might send off 100 queries. You get these 100 results, and then you want to get the average or the mean. You also want to get the median and the quartile information, the percentiles. And all of them are displayed over here. Now let's dig deeper into the heart of the talk, which is using OpenSearch Benchmark to track the performance of your cluster. And let me hand this over to my co-presenter, Ian Hoang.
All right, thanks, Govind. Yeah, now that y'all understand how OpenSearch Benchmark works internally, we can dive into how we use it to track performance overall. So every night, OpenSearch community has clusters that are being spun up and run against different workloads from OSB. These workloads focus on time series data, full text search, and segment replication. So if you visit that link right there, you'll see a UI similar to the one here on the right of me. At the top, you'll see the different workloads that you can switch between, the time frame you can toggle. It's showing the last 7 days worth of data. And then you can also see the cluster configuration that the workload was run against. So if you scroll down, you'll see a bunch of different metrics that are being collected and visualized every night. In the end, this serves as a great way to kind of see performance patterns and trends for different distributions and configurations over time. So maybe we'll click on one of these charts here, and we'll see that this one is focusing on query latency for security-enabled cluster configurations. And as you can see, most of them are below the 100 millisecond time frame, but some of them are also above the 300 to 400 millisecond range. And these results are also downloadable as CSV files, and you can also export them to other analytical tools such as QuickSight and Tableau. Another great value that these runs add is that it allows you to see performance patterns, specifically performance improvements and regressions throughout time. So for here, this example here, we're looking at aggregation query latencies for cluster configurations that have security disabled. As you can see, most of the cluster configurations here are around the same ballpark, except for 2, which are the yellow and the purple lines. This usually signifies that there's been a regression that occurred because the latency jumped up, and maybe in the last 2 weeks, we checked in a change that caused this. So it really helps us identify leads on maybe commits that are introducing these regressions. So these nightly runs overall act as a great guidepost in understanding how different distributions of OpenSearch and configurations perform in real time against different workloads. And they also give users confidence because they're run on a periodic basis and they're easily reproducible. So now that you understand how we're using it to track overall performance, you probably are wondering how you can use OpenSearch Benchmark to get to know your cluster and ultimately unleash your cluster's potential. Some callouts that we want to have are these common issues that many of our customers see in their clusters. And the first common issue is static configuration issues. These are a little bit more subtle, but usually clusters might have too many primaries or too few replicas. The shard sizes might not be ideal. You might have underpowered node types, or maybe you just don't have enough nodes. These can often lead to bigger issues, such as dynamic runtime issues like high JVM memory pressure, high CPU utilization, hotspots, and even GC pauses. These can ultimately bring down a cluster, so you really want to make sure that these issues are not impacting your cluster. And we recommend looking at a bunch of best practice guides and tutorials on how to identify such issues and resolve them. So just rule these out before running OSB, because you want to just ensure that these aren't the primary causes of performance issues in your cluster. So the first strategy that we recommend is going home and setting up an OpenSearch test cluster. And we also recommend that you set up a load generation host with OSB installed. You should pick a workload that is similar to your domain. So maybe you're developing a rideshare app, and the best official workload that you could use is NYC taxis that Govind mentioned earlier. And you want to run iterative tests to see if you get repeatable data. Optionally, you can also store this data into an external metrics data store, like what we did with the nightly runs, and you can visualize them and compare them in the future. You can also run these tests and run the same steps for your production cluster. If you're able to do that, don't worry, because these workloads are pretty small and they don't really affect performance on like a cluster like your production cluster. And essentially, if you're able to do that, you would have 3 sets of data: the test data from the test cluster, the data from the production cluster, and the data from the nightly runs. So overall, this should give you a good idea about how your cluster performs against a specific type of workload. You'll see the different similarities and count for some of the differences, like instance types and node types. The next strategy we recommend is getting a little bit closer to the official workloads and playing around with different workload parameters. You can change them to see how it changes performance on your OpenSearch test cluster and ultimately understand a potential sweet spot. So maybe that's running tests with different shard counts, different number of replicas and primaries, or running with more client threads. So to better illustrate this, we have a diagram here showing a load generation host with OpenSearch Benchmark installed. It's pointing to a test cluster that we set up, and the official workload that we chose creates an index with 5 primaries and 0 replicas at default. Then it progresses to the ingestion phase, and then it progresses to the search phase with 1 search client. So maybe when we want to shake things up a bit and run with 1 replica to see if that changes the read performance, we'll run that a few times, maybe calculate the averages and the median and just see how that performs. And then maybe we feel like ingestion has been causing some variance in the queries because of different amounts of ingestion in each test. So we might want to restore from a snapshot instead to keep things consistent. Or maybe we want to leverage the load generation's host CPUs and run with more search clients and amp up the overall intensity of the test. Or maybe we want to run against a different test OpenSearch cluster and just a beefier cluster and see how that performs with the original test cluster. The possibilities are really endless, and you can match and combine different workload parameters to see how your cluster performs against different scenarios. So here's a situation where someone might be interested in seeing how different shard counts impact ingestion throughput. Maybe they have like a 3-node cluster, and they're just running these tests to confirm this OpenSearch concept. But maybe they run the first set of tests with 1 shard, and then 2 shards, and then 3 shards, and then all the way to 7. Then they realized, after plotting the data points, that, OK, 3 shards is the most optimal because it's the top of that peak right there. And after that, it's just diminishing returns. Many of you might run into an eventual roadblock, which is what if the official workloads, like none of them match my use case? So like maybe you've been playing around with NYC taxis, HTTP logs, and Big Five, and in reality, your production cluster workload looks like financial data, like here on the left. What can you do? So OSB comes with a feature called create workload, and essentially you can provide a cluster endpoint filled with data, and OSB will go and fetch those documents from that cluster. You can specify the number of indices you want, the number of documents from each indices, and OSB will structure a workload similar to the other ones, but just with your data. It'll also append some bare-bone queries that are pretty common, and that way, when the workload's created, you can just immediately run it on a test cluster. But there is one caveat that we want to bring up, which is many users will run their custom workload immediately after it's been produced and say, like, OK, this custom workload should produce metrics similar to my production cluster, right? Usually that's not the case because, as I mentioned earlier, some bare-bone queries get added by default. What this custom workload feature doesn't get exposure to is the queries that are run on your production cluster. So you first need to also understand the characteristics that you want to bring over to this custom workload and build the custom workload based off those characteristics. So we've developed this process to help build custom workloads that are representative a lot better. And the first step is understanding which characteristics you want to bring over. So maybe the characteristic that you want to bring over is a shard size. You want to match the shard size seen in the production cluster. So to do that, like maybe your shard size in your production cluster is 25 gigabytes. And you'll need to extract enough documents, do some calculations, and tell OSB, OK, I want this many documents from this many indices in the custom workload, and that will ensure that you still retain that shard size of 25 gigabytes. We next recommend that you actually get real queries from your production cluster and go through them, pick a specific time frame. So maybe if you could set up a log stream connected to your production cluster and check a specific time frame that you're interested in, and go through those queries in that time frame and create a subset. So to better illustrate that, like maybe you're interested in the time frame where your cluster receives the most traffic. That might be from 1 p.m. to 3 p.m. You look at that time frame, you extract those queries. Maybe you had like 10,000 queries run on your production cluster. Then you'll look through and try to understand the composition of those queries. You'll see, OK, how many of these queries are sorts? How many of them are ranges? How many of them are aggregations? Then you'll create a subset based off that superset, and maybe you'll just have about 25 queries. But you still need to ensure that the composition is relatively the same. You'll then inject that subset into the custom workload, and then you're basically ready to run this test. So step 3 is running this test on a test cluster that is similar in configurations to your production cluster. And you'll run the test a few times, and you'll compare the metrics. You'll see, OK, are the metrics that I'm seeing in my test cluster similar or identical to the production workload? And if it's not, you want to go back to the workload parameters, and you want to see, OK, which parameters can I change to bring the metrics in my test cluster similar to the production cluster? And it basically becomes this iterative cycle. So maybe your CPU utilization you've seen in your test cluster was only 10%, but the production cluster was around 30%. So maybe you need to go back and look at specific parameters like search clients or amping up more iterations or having a longer time period of operations running, or maybe even setting target throughput. So overall, we have this process for building custom workloads, which is first extracting the documents and the queries based off the workload characteristics, then running the test iteratively and comparing metrics. And if they don't match, go back to the workload parameters, change that up, run the test to see how the subsequent tests compared to the production workloads. And sometimes you might have to go backwards and extract more queries or extract more documents, but this is essentially the cycle that we've developed. And in the end, you'll have a custom workload that is relatively different from your production workload. It might not have the same size of data. It might have less indices than your production workload, and it definitely has less queries, but it essentially captures the essence of your production workload and is a smaller model of your production workload. And there are several benefits of having a small model of your production workload, which is that it serves as a safe environment where you can explore new test features. You can also explore other workload parameters and combinations to see how that can optimize your production workload, and any findings you can bring over to the production workload. It's also more portable than working with a snapshot every time you want to just test new things. And overall, it gives you confidence in making changes to your production cluster. So we actually had a case last year where a customer came to us and said, hey, we really want you to build us a custom workload. We'll provide you all the data that we have. We'll provide you any queries if you need it. And we want to run this whenever we're testing a new feature or we want to see if we want to move to a new OpenSearch version. So to illustrate this more, they were on OpenSearch 2.9, and they were really interested in OpenSearch 2.11 and some of the features that it offered. But they didn't really want to commit to the migration yet because they didn't know if any regressions existed in 2.11 that they weren't aware of, or they weren't sure if what exactly the improvements were in 2.11 on their specific workload. So we took a look at their workload, and it turns out that there was about 5 terabytes of data split across 7 indices. And it was a relatively large cluster. It had over 15 data nodes. And they also provided us with some of the queries that they thought were representative in their production cluster. But it turns out we asked them, hey, can we actually get a bigger time frame that you're interested in and extract the queries directly? And we actually got a bigger set of queries that were actually more complex than the ones they provided us. Some of the common questions we had was, how much smaller should this custom workload be? What are the parameters we should be focusing on? How do we even choose which queries should be added to the custom workload? How long is the process building a custom workload like? And what if in the end we can't even get the metrics to match the production cluster? There were also several complications that we saw. The cluster configuration was very big and constantly evolving over time. One week it was 15 plus data nodes, and the next week it scaled down to 9 data nodes but changed its instance types. The cluster was also dealing with heavy ingestion and search operations, which saw occasional spikes in CPU. And the data corpus was constantly being updated and increasing in size. So what did we do in the end? We took a snapshot of the production cluster and we worked off of that while it continued to evolve. We used OSB to create a custom workload that was 1/5 of the production cluster size. The 1,500 queries that we got, we actually slimmed them down to 15 queries, and we ensured that they still had the same composition seen in that superset of 1,500 queries. And then we ran the test several times with several iterations with different workload parameters until we got similar CPU metrics and throughput and latency profiles. So these are some of the metrics that we captured in the customer production workload as well as our own custom workload. There are a few callouts we want to make. So the first being the customer production workload is a different scale. Like it runs for a longer period of time compared to our custom workloads charts. The gaps seen in the custom workload are just times where we weren't running the tests because we were just running short experimental tests to see if we were getting the same metrics. There was also a difference in the peak sizes. So as you can see in the custom workload, those 2 arrows pointing to 2 different peak sizes. These are essentially just time periods where we were playing around with the iterations and the search clients to see if we can change up the intensity. But if you were to overlay the custom workload on top of the production workload, you'll see that they're pretty much identical and similar. The CPU utilization, though, on the customer production workload has many spikes compared to our custom workload, and that's to be expected because that's a randomly chaotic environment where the production workload lives compared to our custom workload, which is a controlled environment. But it's worth mentioning that we can replicate with OSB those spikes. We'll just need to develop a test procedure and operation that can induce the randomness that we see in the customer production workload. The customer was also interested in replicating the OpenSearch request rate levels. And as you can see, we were able to get really close to that. So in the end, after we developed this process, it was our first time ever doing something like this. We circled back to our questions that we had at the beginning. And to answer some of them, we asked, how much smaller should the custom workload be? It's really up to you. But you first have to focus on the workload characteristics. You want to ensure and understand what characteristics you're trying to bring over to your custom workload. And then you can think about workload size afterwards. You should also, for the second question, how long is the process of building a custom workload? This also, again, depends on the number of characteristics you're trying to port over. So the more characteristics you have, most likely the longer it'll take. For us, it was about a month to build this custom workload. And lastly, what if we can't achieve the same metrics seen in the production cluster? We've tried many times, we just don't see it. Unlikely that you're going to get it right on the first time, but we recommend going through this process that we mentioned earlier. And you might have to circle back to previous steps like extracting more queries or extracting more documents. But we believe that through that process, you should be able to get very similar metrics, if not identical. So many folks have used the create workload feature, and some of them have been very happy with it to the point where they've contributed a workload. And this gentleman here contributed the vector search workload recently, and many users have been using it since. In 2024, we plan to add a bunch of new features to OSB. We want to add new workloads. We want to enhance the creating custom workloads feature so that it's overall a better experience. We also want to add micro benchmarks to OpenSearch PRs to catch issues on the fly. We also want to open up a beta feature that we have that increases data corpora for all of the official workloads. And we also want to add support for different cloud service providers other than AWS. So just to wrap everything up, OpenSearch Benchmark is the de facto performance tool for OpenSearch, and it tracks and measures performance. The nightly runs act as a good guidepost for you to understand how different cluster configurations and distributions measure against different operations. And lastly, OSB offers a ton of strategies for you to better understand your cluster and ultimately unleash your cluster's potential. So with that, if you are interested in OpenSearch Benchmark, we highly recommend that you check out our awesome documentation. And with that, thank you for having us.